Hello and welcome to my next video about CANOpen protocol. We will move to the services. Network Management Service takes care about synchronization of state of each device on the bus. This message has a higher priority on the bus. There is only one NMT master on the bus and it ensures a bus recovery. According to NMT states, the devices could be in one of four states. When the device runs up and starts with CAN layer initialization and application initialization, it is in initializing state. When CANOpen protocol is injected, the device is in pre-operational state. It remains in this state until the NMT master broadcasts to switch all devices to the operational mode. In the topology without NMT master, the devices could enter to operational state on internal condition. If the device detects an internal error or bus failure, it switches itself to a stopped state and signals this condition to the address by generating its own NMT message. In this picture, you can see an NMT call. The ID of a message has no node ID, so this is a broadcast call. The length of a message is 2 bytes, where the first byte is 1 hexa, means the device goes to operational. Such output you can get from the CANOpen microchip analyzer. Through emergency service, the device can generate a message informing that it encountered some error. Typical situations are when the device loses connection to the network or synchronization. The message includes the error register flag and error register code, from which you can discover what condition happened. A list of conditions and its error codes could be found in co-emergency header file. For example, if the device sends RxTX passive message, it could have several reasons. The device is not connected, device has bad bitrate, or there is a strong electromagnetic interference nearby. Inhibit timer is a time interval that specifies how often the message is to be sent. A synchronization service generates pulses in fixed time intervals that serves for synchronization on the bus. Upon this pulse, some messages like video objects are transmitted on the bus. There is only one sync producer on the bus. The synchronization object is an equivalent to a clock signal. A heartbeat service is used to detect if the device is in service. A device could be a heartbeat producer, which is typical for end devices like position encoders, sensors, or a consumer, or both. A boot-up message is a message that is sent by a device when it switches itself from state initializing to state pre-operational. It has a code ID 700 hexa plus node ID. Thus, the device signals that it is prepared to be switched to the operational mode. A time service provides actual date and time info. The message has a length of 6 bytes and it is produced only by one device. There is no response to this message. A service data object is a service for transmitting long messages from one device to the other devices. The code IDs of these services are 600 hexa plus node ID for receiving and 580 hexa plus node ID for transmitting. SDO messages are permitted in initial or stop state. The communication is always initiated by the SDO client. In CANOpen terminology, communication is viewed from the SDO server so that a read from an object dictionary results in an SDO upload and a write to a dictionary entry is an SDO download. If your device is an NMT master, you can check the state of other devices by requesting data and waiting for their response. Such a request for node number 2 with answer could look like in the picture. The SDO communication could be expedited, that means that the transfer is shorter than 4 bytes. Segmented means the transfer is longer than 4 bytes. The request-response process is repeated. Each segment carries up to 7 bytes of application data, as 1 byte of the CAN frame is required for protocol information. Any amount of messages could be sent this way. There is only a time slot limit. This is the most common way of communication. Block transfer means that one block consists of up to 127 segments. This is used to transmit large amounts of data. Let's have an example when one client wants to read an object from object dictionary of another node server. From the client perspective, the communication is as follows. Client sets up communication on its side. Client initializes the upload request. Client sends upload request. Client may want to send another request in case of segmented or block transfer or ND communication. The server catches a request in its SDO receive inter-based handler, and this request will be processed in SDO function callback or in SDO process function. Then we will move to more complicated transfers that are provided by a PDO service. Before, I have to also explain the core of Object Dictionary, which I will show in the next video.